Hi students, good morning. Today we are going to discuss the next concept called MAC layer solutions. So what is these MAC layer solutions? MAC protocol determines which node should transmit next on the broadcast channel when several nodes are competing for transmission on that channel. That means MAC protocol is the most important one in that. So what is the main purpose of this MAC protocol means in the broadcast channel which node to transmit the next to determine that one is the main work of MAC protocol. The existing MAC protocol for dark wireless networks uses channel sensing and random backup schemes. So to access like that, the existing protocols for dark wireless networks, they generally using channel sensing. So already we know what is meant by sensing. So the channel sensing and random backup schemes are required. In the carrier sensing, in the channel sensing, we are doing the randomly backup schemes. So randomly comes again into the medium and whether the medium is free or not, checking that one. So it is comes under random backup schemes. So the MAC protocols always using the channel sensing and random backup schemes. The next one is supporting real-time traffic in this network is a very challenging task. So always supporting the real-time traffic is the challenging concept here. Then MAC protocols that provides quality of service support for applications in adult wireless networks have been proposed. Some of these protocols are described below. So MAC protocols always supports quality of service. For this, some of the protocols are proposed here. They are given below. First one, cluster TDMA, time division multiple access. So clustering, we already know what is meant by clustering. So grouping the homogeneous elements. So based on that, Gerlach and Thessard proposed cluster TDMA for supporting real-time traffic in adult wireless networks. In bandwidth constrained adult wireless network, the limited resources available need to be managed efficiently. So, in bandwidth constraint in adult wireless network, only limited bandwidth resources are available that need to be managed efficiently. To achieve this goal, a dynamic clustering scheme is used in cluster TDMA. So to achieve the goal, we are using dynamic clustering schemes. So in this clustering approach, nodes are split into different groups. Each group has a cluster header, so which act as a regional broadcast node and a local coordinator to enhance the channel throughput. So for each cluster, in this cluster approach, the nodes are divided into groups. In this group, we have a cluster header which acts as a regional broadcast node and local coordinator node to enhance the throughput. Every node within a cluster is one hop away from the cluster head. So in the group, each and every node one node away from the cluster head. That means from cluster head to our node, only one hop must be there. So not more distance. So the information of cluster, the formation of cluster and selection of cluster head are done in a distributed manner. So selecting the cluster and cluster header is done in the distributed manner. Then clustering algorithms splits the nodes into clusters so that they are interconnected and cover all the nodes. So how we are creating the clusters means with the help of clustering algorithms. These algorithms split the nodes into clusters so that you can interconnect. Each cluster can interconnect and covers all the nodes which are exist. So there are three such algorithms are existed. One is lowest ID or algorithm. So cluster algorithms are there we discussed. So there are three different types of such algorithms are there. In that the first one is lowest ID algorithm. A node becomes a cluster head if it has the lowest ID among all its neighbors. So that is nothing but lowest ID algorithm. Second one is highest degree. What is the highest degree? Degree refers to the number of neighbors which are within transmission range of a node algorithm. So degree means refers to how many number of neighbors which are exist within transmission range of the node. So how many other nodes are exist within the transmission range of this node, it comes under highest degree. This is the second algorithm which is used for clustering. And third one, least cluster change. So LCC, least cluster change algorithm. Cluster header change occurs only if a change in network. So when the cluster headers may be changed, means only there is a change in the cluster network. So if the network is changed, then cluster address is also header is also changed. So these are the three different types of algorithms we are using for making clusters. Then the time division multiple access scheme is used within a cluster for controlling access to the channel. So controlling the channel access is maintained by time division multiple access schemes. So in the scheme, how it is maintained? Yeah, synchronous time division frame is defined to support TDMA access in a cluster and to exchange control frameworks. So mainly we discuss the time division frame is defined to support time division multiple access in clusters and exchanging the control information also. So each synchronized time division frame is divided into slots. So such a time division frames are divided into slots. So those slots and frames are synchronized through the network. So this time division frame is split into two phases. One is control phase and second one is data phase. So control phase always used for carrying control functions such as routing, clustering and synchronizations. And second one, data phase is used for data transmission. So control phase is used for control function transmission and data phase is used for data transmission. And when you come to acknowledgements, acknowledgement packets for each frame is sent in control phase. So control phase itself we are sending the acknowledgements. So in this manner in time division environment the data we are transferring. Then come to the second proposed protocols means IEEE 802.11e. So in that first point IEEE 802.11 MAC protocol. So it supports two modes of operations. So this MAC protocol supports two modes of operations. Namely, one is DCF, distributed coordination function. Another one is DCF. First, we are going to discuss distributed coordination function. What is this? This mode does not use any kind of centralized control. That means centralized antenna or centralized controller. So this mode does not use such type of centralized controllers. Then point coordination function, it uses the centralized coordination. So what is that? This mode requires an access point. So AP, access point, which act as the centralized controller to coordinate the activities of all nodes in its coverage area. So in its coverage area, what are the other nodes are there? To coordinate that one, we require centralized coordination function. All implementations of the 802.11 standards for wireless LANs must provide the DCF mode of operations, while the PCF mode of operation is optional. So all the wireless environment that provides DCF mode, PCF mode is optional. Then the time interval between the transmission of two consecutive frames is called interframe space. So the time between the two interval consecutive frames is called interframe space (IFS). So there are four IFS defined in IEEE 802.11 standards. I think we already discussed these things, but once again, according to the concept, we are discussing here. So there are four different types of IFS are there in 802.11 standards, namely short IFS, PC IFS, DCF IFS, and extended IFS. So these are the four different types of 802.11 standards are there. So the relationship among them is as follows. So SIFS is less than PIFS and it less than DIFS and it less than EIFS. So this is the relationship exists between the interframe spaces. Then second point, distributed coordination function. So what is this distribution coordination function? If a station A wants to transmit data to station B, station A listen to the channel. So first point, it is channel sensing concept. If a channel wants to transmit data to station B, so first station A wants to listen the channel. Then afterwards, if the channel is busy, it waits until the channel becomes ideal. After detecting the ideal channel, station A further waits for the DIFS period and invoke a backup procedure. Channel is ideal even though it introduces or it invokes DIFS period for backup procedure. After this period is closed, then only it starts the transmission. That is the third point. After detecting the channel as being ideal for a DIFS period also, then station A starts decreasing the backoff counter. Once the backoff counter reaches 0, then station A transmits a RTS, that means request to send frame, and wait for the clear to send frame from the receiver B. So this is the technique which we are used in the distributed coordination function. Simply I am saying station A wants to transfer the data to station B. Simply station A wants to listen the channel if the channel is ideal or not. If the channel is ideal, even though it invokes DIFS period of time to back off the procedure. Even in the DIFS period also, the channel is ideal, it starts decreasing the backup scheme counter. If the backup scheme counter comes to 0, then only station A transmits RTS message and waiting for CTS message receiving from the receiver B. So if it is received, then they will start the transmission. Then third point coordination function. Point coordination function introduced to let stations have priority access to the wireless medium uses the point coordination which operates at an access point. So there we are not using any access points in second point. In third point we are using access points. Then PCF decides which station should gain access to the channel. So this point coordination is the fourth person who decide which station wants to access the channel for transmission. So useful only in infrastructure based network. So point coordination function useful only in infrastructure based environment. So other situations it is not used. Then PCF is not scalable to support real-time traffic for a large number of users. Then fourth point is quality of service support mechanism of 802.11e. The next point is IEEE 802.11e, new standard to support real-time traffic. It is a new standard which supports the real-time traffic. So quality of real-time traffic means, so we know very well about. So just now in our mobiles we are doing video calls. They are real-time concepts. So to support that one, new standards are defined. So this quality of service in both infra-less networks. So it supports both the concepts, infrastructure and infrastructure-less networks. It supports. Then what are those new standards means? One is enhanced DCF and second one is hybrid coordination function. First come to enhanced distributed coordination function support real-time traffic by providing differentiated and distributed DCF access to the wireless network. So enhanced always supports real-time traffic. So this is the mechanism. Example, extended DCF access mechanism. So, so when you want to transmit any data, it wants to wait busy. The medium is busy. That's why you want to wait, and for that period, it transfers the interference spacing concepts, and after the high priority is accessed first. In that priority manner, we are accessing the medium. So if you access the medium first, you want to transfer the RTS message, and after transfer, you want to wait some period, and after you receive the CTS, and after that, you want to wait some period. Then you want to transfer the data. After transfer the data, you want to wait some period and receives the acknowledgement in this format. The eDCF access mechanism is there. So it is mainly used for supporting real-time traffic. And third one is hybrid coordination functions. What is this hybrid coordination functions? Combines the features of eDCF and TCF to provide the capability of selectively handling MAC service data units. So in hybrid coordination function, both eDCF and TCF is available combinedly and selectively handle the MAC service data units. So the second point is as upward compatibility with the DCF and PCF. So these hybrid functions are the best compatibility, upward compatibility with DCF and PCF, usable only in infrastructure based BSS and provides quality of service. So this concept may be used only in infrastructure based BSS uses quality of service aware point coordination called HC, hybrid coordinations. Then this is nothing but the HC of hybrid coordination function access mechanisms. So also the same concept will be used. Then third concept is DBAS, distributed bandwidth allocation share extension protocol, supports multimedia traffic. So this protocol mainly used for multimedia traffic, both variable rate and constant bit rate over adapt wireless networks. So mainly this DBAS is used for supporting multimedia traffic. In an adapt wireless network, there is no fixed infrastructure. There is no any fixed infrastructure to coordinate the activities of individual stations. Then for real-time traffic, a contention-based process is used in order to gain access to the channel. So multimedia traffic means that we are using nearly more real-time traffic. So contention-based process is used in order to gain access to the channels. Then D-based protocol permits real-time stations to access bandwidth on demand. So for D-based protocols permits real-time traffic stations to access bandwidth on the basis of on-demand basis. So the non-real-time stations regulate their access to the channel according to the standard carrier sense multiple access collision avoidance protocols. If it is real-time, with the help of D-based protocols, it it acquire excess bandwidth. But if it is a non-real-time stations, it regulate their access. So in that number of protocols are there. In that the first one access procedure for non-real-time stations, how the non-real-time stations are accessing. So means the channel access method for non-real-time stations is based on conventional DCF, and non-real-time stations with data traffic has to keep sensing the channel for an additional random time called data backoff time after detecting the channel as being ideal for a DIFS period. The data backup time is given by. So for non-real-time stations, the traffic has been kept sensing the channel. How we are maintaining the traffic means in non-real-time stations by sensing the channel and additional random time called data backup time after detecting the channel being ideal for DIF period. The backup time is given by in this manner. So data backup time is equal to random of A comma B into time slabs. So this is the first concept. Then second one is access procedure for real-time stations. So that is access procedure for first point is access procedure for non-real-time stations. So how we are accessing the channel means by sensing. But when you come to the access procedure for real-time stations. So for real-time, how their access procedures are working means each real-time stations maintain a virtual reservation table. So real-time stations how we are accessing is with the help of reservation tables. In this virtual table, the information regarding all real-time stations that are successfully reserved, the required bandwidth is recorded. So in the virtual reservation table, all the information regarding all the real-time stations are successfully gathered and stored or reserved and required bandwidth is also recorded. So based on that, without any problem, the real-time stations can access the data in by using virtual reservation tables. Therefore, before initiating an real-time sessions, the real-time stations send an RTS in order to reserve the required bandwidth. So, for this, real-time station sends RTS to reserve the required bandwidth. Before transmitting the RTS, a corresponding entry is made in the reservation table of the node. So before doing transmission, we are reserving the bandwidth with the help of RTS sending to the stations. So every station that hear this RTS packets also make a corresponding entry in the reservation table. So within the RTS message, so your device wants to transfer any data in the real time means that device sending the RTS message. This RTS message is accepted by all the station nodes and make its corresponding entries changes in the RT reservation table. After recording all the reservation tables successfully, then real-time stations need not contend for the channel anymore during its whole session. So for the whole session in the real-time environment, what's the data wants to transfer, it must be transferred without having any problem because what are the resources are required including bandwidth is reserved. So that is the concept of accessing procedure for real-time sessions. Then bandwidth reservations. So this third concept, bandwidth reservation, is nothing but whatever the bandwidth you require to transfer the data in the real-time environment from sender to receiver, all the bandwidth is reserved at once. After completing the total session only, it will be relieved to the others. So this is the concept of MAC layer solutions. So these are the three different points we need to remember in this concept. Thank you.